This is 9.3 angles of elevation and depression. I have a boy looking up at a plane. I have a horizontal line right at his eyesight, his line of sight. He's looking up at the plane. The angle that's made by this horizontal line and the angle where he is looking at the plane is called the angle of elevation. By the same token, if I'm in the plane, I have a horizontal line, my line of flight. I have the angle that I'm looking down to see this boy. The angle that is formed here is called the angle of depression. Please read the note at the bottom. Students sometimes make the mistake of thinking that the angle of depression goes with a vertical line. What does that mean? A lot of times when they ask for the angle of depression, they'll draw a vertical that didn't work. They'll draw a vertical line down from the plane and think that this is my angle. The angle of elevation and angle of depression never deal with a vertical line. They always have to do with the horizontal line. Notice if I have two horizontal lines, both of these lines are parallel. The angle of elevation and the angle of depression are alternate interior angles, and therefore if the lines are parallel, those two angles have to be congruent. So the angle of depression is always the same as the angle of elevation. Sometimes that helps us stop from making a mistake. What are we going to do with this angle of elevation? I've got a kitten standing 10 feet from a counter with cookies on top. The kitten uses a tool called a theodolite, I believe, and determines that the angle of elevation to the top of the counter is 23 degrees. Please don't ask me what a theodolite is or how the cat even managed to know how to use it. He apparently is brighter than I am, but he does know that he has a 23-degree angle in his line of sight to the top of the counter. He's standing exactly 10 feet away from the counter, and what he wants to do is he wants to know how high the counter is to know if he can actually jump up and get those cookies. How are we going to work this problem out? Well, look what we've got. We've got a right triangle, and compared to the right triangle, I'm trying to find this red line. The red line compared to this 23-degree angle is the opposite. The 10 feet is the adjacent. And the thing that we're not interested in this time is the hypotenuse. Which trig function is going to use the opposite and the adjacent? Why, the tangent function is. So I'm going to say that the tangent of 23 degrees is equal to the opposite, which is what I'm trying to find, over the adjacent, which is 10 feet. All we have to do to figure out the height of the counter is to multiply the tangent of 23 by 10, and that will tell us. I didn't bring up my calculator, sorry, give me just a second. It takes a little while on this debugger. If I can figure out how to edit this out, I will. That will be exciting. Otherwise, you can just watch me fumble through this. Let's try and put this down into the area where I know it's going to actually be seen. And what am I doing? I'm doing 10 times. By the way, I have to turn this on. I have to change my mode every time I do these, which is why you should always be prepared before you start a video. There's my degrees. Now I'm going to do 10 times the tangent of 23. And so the counter is about 4.24 feet high. It's the same thing we've been doing with trig functions. It just uses the words angle of elevation and angle of depression. Let's look at another example. This time I didn't draw you a picture. You'll have to learn to draw it on your own. An airplane is flying 3,500 feet above the ground. So I'm going to make my airplane. My students will tell you that I'm quite the artist. There's my airplane, believe it or not. It's flying 3,500 feet above the ground. So it's making a right angle with the ground. And it begins a 2% descent to land. So my angle of depression is going to be 2%. It's just going down 2% at a time. I probably should have given myself more land. And pretend that I just drew a straight segment. The dashed segment is supposed to be straight. I'm not supposed to be making any sort of parabola or anything. And so this angle of depression is 2 degrees. If this angle of depression is 2 degrees, notice that the angle of elevation over here will also be 2 degrees. We want to know how far line of sight means from the airplane down to this airport. That was a little better line, wasn't it? How far is it from the airplane to the airport? Got my air traffic controllers in there somewhere also. Well, compared to this 2 degree angle, once again, this is the opposite. This time I'm looking for the line of sight, which is this part. That's the hypotenuse. Which trig function uses the opposite and the hypotenuse? The sine function does. So the sine of 2 degrees is equal to the opposite, 3,500, over the hypotenuse, which is what I'm trying to find. Those of you that have been in my class know we can switch the two around. The sine of 2 degrees and the x can be switched. And so x is equal to 3,500 divided by the sine of 2 degrees. Well, what is 3,500 divided by the sine of 2? Let's find out. 3,500 divided by the sine of 2. That is 100,287.98. We'll put it up here, 100,000, see how quickly I forget, 287.98. But remember, it asked me how many miles to the nearest mile, how far am I away? I put feet. Grace tells me that there are 5 tomatoes in a mile, so 5,280 is a number of feet that are in a mile. To figure out the answer, I'm going to divide this by 5,280. This number divided by 5,280 is 18.99, which is approximately 19 miles. Problem 1. An ant is looking up at you with an elevation of 24 degrees. You're 5 feet tall. To the nearest tenth, how far is the ant from your foot? Please stop the video and try this now. Hopefully you drew an ant. Pretty little ant there. He is at an angle of elevation. So here's my horizontal line. Here's my angle of elevation at 24 degrees. Understand that I am 5 feet tall. And to the nearest tenth, how far is an ant from my foot? Notice that the ant from my foot, oops, I'm going to close my legs here. Now both my legs are together. How far is the ant from my foot? Compared to the 24 degree angle, this is the opposite. I am trying to find the adjacent. Which trig function uses the opposite and the adjacent? The tangent does. So the tangent of 24 degrees is equal to the opposite over the adjacent. So the x is going to be equal to 5 over the tangent of 24. I want it rounded to the nearest tenth. 5 divided by the tangent of 24 is about 11.23 feet. Rounded to the nearest tenth, that's 11.2, so I don't have to worry too much. The ant's still pretty far away. I may have to walk over there and squash him because it already looks kind of like I already did. Problem 2. This is the last problem we'll try for now until we get to class. Bob is looking at a helicopter that's flying 1,000 feet above the ground. Bob is 1,500 feet. Bob is, kind of went off the screen there. Bob is 1,500 feet from line of sight from the helicopter. To the nearest degree, what is the angle of elevation? At what angle of elevation is Bob looking at the helicopter? You probably solved it by the time I actually got through reading this out to you, but try it now. Okay, I've got a helicopter. Here's my helicopter. See the rotors on top? All right, so my helicopter looks like a tree. Anyway, I don't care. A tree on top of a whale or something. Here's Bob. Bob's down here looking at it. And it's flying 1,000 feet above the ground. So there's my 1,000 feet. And Bob is 1,500 feet line of sight. Here's his sight to the helicopter. This is 1,500 feet. This is making a right angle to the nearest degree. The angle of elevation is this one. Please remember, when I'm looking for an angle using these trig functions, I always have to use the inverse trig function. In this particular case, compared to x, 1,000 is the opposite, 1,500 is the hypotenuse, so I'm using the sine. The sine of x is equal to the opposite over the hypotenuse. So x is equal to the sine inverse of 1,000 over 1,500. I would say 2/3, but we've got a calculator that will do that for me. So I'll just leave it as 1,000 over 1,500 and see what happens. This time, instead of doing the sine, I'm doing the sine inverse, so I have to hit second sine. The sine inverse of 1,000 divided by 1,500. It's approximately 41.8 degrees. Let me double check. I'm looking for it to the nearest degree. To the nearest degree, it is 42 degrees. So x is equal to 42 degrees as rounded to the nearest degree. We'll be doing a lot more problems in class. Hopefully this gives you a start on angles of elevation and depression.